We're going to start section 4 of chapter 4 now. So we're going to discuss putting a complex number that is in standard form into what is known as trigonometric form. So we have this formula for trigonometric form here. And notice again, we're using the letter Z. So we use Z in each of the previous sections when talking about complex numbers. Z is kind of the go-to letter, so that's what we'll be using. If we're looking at different complex numbers, we'll give one of them, say Z with a subscript 1, and the other one Z with subscript 2, and so forth. All right, so the formula, R times the quantity cosine of theta plus I sine of theta. So the cosine of theta is the real part. The sine of theta is the imaginary part. And the R is this absolute value of our complex number, which we have already done. We did this in the first section. And recall that we have this here. So the absolute value of our complex number is the square root of the squared coefficients added together. Okay, so the process for this is to first plot where your complex number is, or at worst, determine what quadrant you're going to be in. You're going to need to know this when calculating what theta is. So theta is going to be your argument, which is the angle where your angle where your line would be from your point to the origin. Okay, so I picked out two problems from the book to try to do. These are both on page 340 in one of the sections I had you doing problems. So I'll use this graph on the right to graph our point. So first of all, I'll leave green there. Or maybe I won't. Okay, we're good. All right. So instead of going, each one of the dashes will be 1, I'll go, this will be 1, this will be 2, this will be 1, and this will be 2. I'm doing it here. We see in problem number 7, we see that we have a positive value of 1 and the I is 1. So our point is going to be at 1, 1. This in blue here will be our point. That's 1, 1, or 1I, essentially. All right, so our R is going to be the distance that we have from our point and the origin, that distance. All right, so let's try to do that. So again, this is number 7. So R is equal to the square roots. In this case, both of them are 1, so 1 squared plus 1 squared. So that's just 2. So root 2. Okay, so if we had to create a triangle here, we would have 1, 1, and root 2. Well, this should give you a pretty good idea where it's at, plus our picture should determine where it's at. Now, our instructions tell us to take the tangent of theta equal to b over a. So that would mean that tangent of theta will equal 1 over 1, which is 1. Now, we note that we're in quadrant 1. So this happens at 45 degrees, or what would be pi by 4. So this means that theta is equal to pi by 4. Now, the rest of our highlighted formula up there, we just need to plug in. Let me scroll down. So we have our equation. Z is going to equal our square root of, R, which is root 2, square root of 2. And then this is going to be cosine of pi by 4 plus I sine of pi by 4. And that is going to be the trigonometric form. You're not solving for cosine, you're not solving for sine, you leave it in this form. All right, so let's try to do number 17. And I've got another one of these down here. Let's move it up. All right. So number 17, and I'll just rewrite it over here. So we may have to scroll down again. -7 plus 4i. Now I'll certainly use this as a regular grid, one for each dash. And I'll mark the first one here as 1, and this one's 1 as well. All right, so -7 would be 1. Well, that's the whole grid. All right, -7 and then +4. So this is my point, -7 and +4. So we're looking for r. R is going to be the distance from here to the origin. You see it's, again, making a nice little right triangle. And our theta will be this. So we're in quadrant 2. That's going to be important when determining whether our values are positive or negative. And strictly just finding our root there. All right, so our r is going to equal the square root of -7 quantity squared plus 4 squared. Well, this one doesn't come out as nice or neat as the other one, but let's find out what it is. It's 49 and 16. Is that 65? And there's no square value that's in 65, so we're just going to leave it alone. All right, so now we need to find the theta. And again, we're going to use this tangent of theta is going to equal, we have -7, -7 and 4, but it wants b over a, so we take 4 over -7, which means theta is equal to the inverse tangent of 4 over 7, or -4 over 7. So let's grab a calculator. All right. So first, I want to change this and make sure it's in radians. So mode, I've got it in degrees. I'll change it down to radians. Arrow down, hit enter, and I should be good, and I can quit out of that. All right, so I want the inverse tangent of -4 over 7. So in this, I use the second button and the tangent button, which will give me the inverse tangent. I use the dash down to the lower left, not the minus key. And we're looking at 4 divided by 7 and close parentheses. So I've got -0.519. Well, that's not going to be what I want. We're looking for something between 0 and 2 pi. So we have tangent, and inverse tangent is periodic by pi, so we can add pi to that. So I can simply add pi. So, and there's a button for pi. I think it's that one. Nope, that's E. It's the one. It's. I'm having problems. Oh, this one's using alpha. All right, so alpha and then. Well, we'll use 3.14. That'll be close enough. So our theta is going to equal positive 2.62. That's in radians. So theta is equal to negative 0.519, I think, and then plus pi, which is about 2.62. And again, this is in radians, which is typically what we do with these. All right, so finally, our formula is going to be z equals the square root of r, which is square root of 65. And then we have cosine first. So cosine of theta, in this case, it's 2.62 plus I sine of that same 2.62. And that's how you put something into trigonometric form. And we'll have some uses for this in the upcoming sections of how we can easily do some manipulation with taking the square roots, squaring. It'll be much easier than trying to just manipulate. You know, one plus I, not so bad. -7 plus 4i, pretty difficult to do.